Hi everyone, and welcome to Erik's Electronics Workbench. So on the bench today I have this Fluke 199C Scopemeter. Now the problem with this meter is that the fan is noisy, so when it's powered on, the fan makes kind of a rubbing, bumping, or almost ticking sound. So let's get started and see what it takes to correct this issue. So the first thing I'll do is just to power up the meter, and you can hear the sound that it's making. So the screen is turned on, but there's some glare, so I don't think you can see it on the camera right now. But you can probably hear that sound that it's already making. I'll just bring this a little bit closer to the camera. Pretty noticeable sound that the fan is making. Now if I turn the meter on its side like so, see this noise pretty much goes away. And then as I bring the meter back more flat on its back, sound is definitely more noticeable. So we need to see what's causing that problem and correct it so that this meter is quiet when it runs, doesn't make that sound. Now you can see there's a notice that comes up when the meter is powered on, and it looks like no one took the time to enter in the code that unlocks the extra memories. So I don't know if Fluke will still honor that code or not, but I have to investigate that. That's a separate issue. If anyone knows what that code might be, please leave that in the comments section below. I'm not sure if that code was unique for each serial number or if just one code was issued and that would unlock any of the meters, but if someone has information about that, feel free to leave that in the comments section. So it's not very interesting to watch me take this apart, so I'll disassemble it, and then when I have things taken apart and access to the fan, I'll continue on. Alright, the scope meter is straightforward to disassemble. Use the number 10 Torx bit and start by removing those two end covers. There's two screws in each of those covers, so get those out of the way. Then you need to remove the back cover off the instrument. There are two screws along the back edge of that cover, so you remove those two screws, and then this cover slides back a little bit and lifts out of the way. With that cover off, you'll have access to the battery pack, so go ahead and get that unplugged and get it removed. This shield right here goes on this area of the circuit board. It's optional to remove it. It's not required, but I wanted to inspect the electronics in this area, so I went ahead and removed that shield. But then the next step that you need to do is to separate the main part of the instrument, the main circuit board, from this front assembly. So this is the display and the keypad, which I have on this towel just to protect it so it doesn't get scratched. So to remove these two, or separate these two, you need to unplug these various ribbon cables and the high voltage connector for the backlight on the display. So those are in this area right over here. So you get those unplugged. There's two screws right here and one over here. Remove those, and then this assembly has a little clip that goes in this front edge right over here. So you just slide this assembly forward and then just lift it away. So I'll remove this out of the way here. We don't need to worry about that. And taking a look at this assembly, you can see the fan is then on the back side. So I'll zoom in a little bit closer and let's take a look at that. Alright, I have the fan removed from this back mounting surface, and you can see these two threaded holes right here. So normally the motor sits like so, and then there's two screws and two little spacers right there that hold the fan in position. So the airflow comes up through this hole right here, goes into the fan, and then it's exhausted out the slot on the side. There's a little arrow right there showing the airflow direction. Now I've also unplugged the fan motor from the main circuit board so that I can power this up with an external power supply, and we'll see how it's functioning. So when I rotate the fan, it does turn okay. You can see it seems free and not really binding up. The fan is not rubbing or touching on anything, so that's a good sign. But I think what's happened is that the bearing has become very dry in this motor. If I press from side to side on the hub, you can feel just a little bit of a clearance back and forth, almost like the hub is rocking back and forth just a little bit. So hopefully getting some oil in there, just a tiny drop of oil is all it'll take. But that will help to cushion that bearing, and hopefully it'll run smoothly and quietly at that point. So I think what's happening is that this is basically setting up a vibration as it's running in there and basically shaking around. Now these motors from what I can tell, are no longer produced, so finding a new motor is very difficult. And you do see used takeouts. They are available, but they're very expensive for what they are, oftentimes priced at $100 or more. And of course, we have a used motor right here, so let's not go out and buy another used motor. Let's make this one work. If I bring this up a little bit closer to the camera, you can see the label on that motor. It's a 5-volt motor. It says maglev on it. I believe that was referring to the type of bearing that this motor uses, probably magnetic levitation. Helps the bearing to basically float with very low friction. So I'll set my power supply to 5 volts and we'll power this up, and let's see if we're getting that same noise. I suspect we will. And do that now. Here, grab these test leads here. So I have a little pin in the end of each of these test leads here, these little alligator clips on the end, and they can poke into this connector here. All right, and power supply set to 5 volts, so we'll turn it on. And the motor is running. Yeah, so when I hold that motor, I can feel a vibration, not surprising. If I touch the engine of the motor, if I touch it right down here, it kind of amplifies that sound. I almost hear it a little bit louder when it's against the surface too. That acts like a speaker or a resonator and kind of makes the sound a little bit more noticeable. But I can definitely feel a vibration when that's running. It's not very smooth. So again, I think that hub is vibrating and kind of shaking around in there. You can probably hear it right there. It gets more pronounced at different angles, which we had noticed before when the instrument was tilted around. So the next thing that I will do is to try and remove this label on here. Power this off. So get those out of the way. So this label is probably covering a hole or maybe several little holes in this hub. And what I'll do first of all is just to photograph this for future reference. So I'll have the part number and the information that was on this label. But using like basically a razor blade, get this label off, and it should uncover a little hole that's under there, and then that'll allow a little drop of oil to be placed into the bearing. So I'll do that next, and then I'll be back and I'll show you exactly how I'm adding the oil in with that label removed. Okay, I removed the label from the fan hub, and you can see it did expose 3 little holes right there. So I was able to apply some oil down into those holes, and it worked its way into the bearing, and now the motor is running noticeably quieter. So I'll power it up in just a moment and you'll see the improvement. So I just used this little needle tip applicator right here, put the oil down into those holes, and the label that was on this hub right here is right here, and it actually survived. It didn't tear. Adhesive still seems to be okay. So I'll try and reinstall that because it'd be nice to cover those holes so lint and dust doesn't make its way into there over time. Now on the back side, I noticed there was another adhesive cover that was on this area right here, so I removed it to see what was underneath. It's this little black circular dot right there. This looks like a piece of brass material with plastic around it, so obviously it's part of the back side of the motor, but I'm not sure if it's pressed into this aluminum or if there's an epoxy or a glue of some sort that they used when assembling that. So I didn't want to try and press that out of this housing because I was afraid it might end up destroying something and breaking it. So I settled for just applying the oil on this side right here. Now the oil that I use is this right here, and you can see it's made by Atlas. So Atlas is a manufacturer of model railroading equipment, locomotives and so on, and this is an oil that they sell. I found it works very well. It's made for small motors, and it's also plastic safe, which is a very nice feature and necessary. You don't want an oil that would attack the plastic. So the oil itself has the right consistency. You can see kind of in the bottle there when I tip it. It's, not super thick like grease, but it's not as runny as water. So it has the right consistency, and basically, it hangs around when you apply it to a bushing or a bearing or something like that. And it doesn't just, dry up and evaporate or anything like that. Also, I found it does not turn to varnish which is important. It doesn't get real sticky and tacky over time. It retains its lubricity and continues to function well several years after you've used it and applied it. So I've used that for many years and found that it works very well. All right, let me power up the motor here and turn the power supply on first. All right, so the other fan that you may hear running is just in the power supply, but this fan is now running very quiet. I can bring this up a little closer to the camera here. Very quiet at this point. So I think the problem is solved. Seems to be working very well. Okay, the fan is reassembled, and you can see the label survived and was able to be reused. The adhesive on it seemed to be strong enough still. I don't think it'll fall off, and it was nice to cover those holes again. This cosmetic little adhesive piece that they had on the back was able to be reattached. So the next thing that I'll do is to reinstall the fan onto this back panel, and then I'll power it up, and let's make sure that it still remains quiet, and then if that looks good, I'll go ahead and get the scope meter completely reassembled, and it'll be ready to go. Okay, the fan is reattached to this panel, and I have it connected to a 5-volt power supply. Now it's a different 5-volt power supply than I was previously using, because the other power supply has a fan in it that noise picks up on the camera, and it kind of defeats the purpose of trying to only hear any noises coming from this fan. So I'll go ahead and turn that power supply on and connect it here. All right, that is very quiet. Bring this a little bit closer to the camera. Probably hear just kind of a whirring sound from the air. But all that vibration and other noises are completely taken care of now. So that's working very well at this point. So I feel confident about putting the scope meter completely back together again, and this problem should be taken care of now. All right, the repair on the Fluke 199C Scopemeter is definitely successful. That fan is absolutely quiet now. So if I bring this a little bit closer to the camera, you can tell there's absolutely no noise from that fan. Completely silent. So that's functioning exactly the way that it should now. So this scope meter is ready to put into service on the bench here. So if you enjoyed this video, please remember to give it a thumbs up. And if you're enjoying the videos on this channel, remember to hit the subscribe button. There'll be many more videos like this in the near future. So until next time, take care. Goodbye for now.